Hi everyone. In the previous video, Luigi showed you how to write an LLVM analysis pass. In this video, we will use the analysis Luigi wrote to implement a transformation pass. First, a brief recap. The analysis traverses a function collecting additions that only use constant integers. Now, our transformation will remove the add instructions and replace their uses with the pre-computed sum computed at compile time. Let's get to the code. The first step is updating our header file to include a new addConst pass struct. This will look very similar to the addConst printer pass we've defined last time, except this struct won't need any private variables. Next, we make a new file where we will implement our transformation pass. Remember to update your CMakeList file to include it as well. Similarly to our analysis, our transformation needs a run function. This function returns a preserved analysis object. This object represents the set of analyses that are preserved following a run of a transformation pass. We will explain this in more detail in a bit. The first thing we do is get the result of our analysis. addInst is the vector of add instructions that is collected. We then iterate over the add instructions collected and call the replace addInst with constant function, which we'll define later, passing them as a parameter. Now, it's simply a matter of returning the preserved analysis. We start with a preserved analysis object that represents all the analysis. We then abandon the addConst analysis, since the add instructions it collected were deleted from the program. This means that any other pass that requires addConst analysis will cause the analysis to run again. Then we simply return the preserved analysis. Now let's take a look at the replace addInst with constant function, which is where the real work is done. We start by extracting the first operand of the addition and cast it to the constant int type. We do the same thing for the second argument. We now compute their sum and place that in a sum variable. Now, we replace the uses of the result of the add instruction with the sum we just computed. Then, we erase the add instruction from the program, and with that, we're done. The last step is to register our analysis. This is how a simplified version of our register pipeline function looked like last time. We insert a check if the name is addConst, and in that case we add our transformation to the pipeline. Let's run our transformation pass on the example file we've defined beforehand. As a reminder, this is what the example looked like initially. Again, we use awk to run our pass. Like last time, we have to load our plugin first. Then we specify the name of the pass we'd like to run. The S flag says we'd like the output to be in the textual representation. We specify the input file, and we specify the output file to be foo2 in the examples folder. And this is how our transform program looks like. Let's compare our function's body before and after the transformation. On the left, we have the program before the transformation. On the right, the one after. First, notice how C and D are now missing. And second, notice how the operands of the add instruction that defines F changed. But we could actually go one step further. Notice at this point, F could also be computed at compile time and removed from the program. Let's see that in action. Let's rerun opt. But now let's specify the input file to be foo2 and output file to be foo3. And this is the final version of our transformed program. Although we could have designed our transformation to iterate over the function until there were no more additions to remove, this demonstrates how a real transformation could be potentially called multiple times when compiling a program. And with that, we conclude how to write a transformation pass on top of LLVM. This type of constant propagation is actually done automatically by LLVM, even though no optimizations are enabled. But we think it's a nice example of how to use LLVM's infrastructure to write your own passes. In the next video, we'll see how to write the LLVM base tool. Feel free to send any comments or questions.